Hi everyone. So in this video I'm going to go over briefly the practice test for the exam 1. Note that if you missed a lecture, so for example if you missed a lecture on subatomic particles or if you missed a lecture on organic chemistry or both, I have put links to the lectures down below and they're somewhere around 30 to 45 minutes of lecture so each. So it's just 2 lectures. It'll take you less than 2 hours to watch both of them. I don't recommend doing it all at the same time, but you need to watch those lectures if you missed the classes because this review video is not designed to go into great detail. It's just designed to answer these particular questions in case you're stuck on one and you just want to watch that individual question. I'm going to try to put basically the chapters down in the video description, so basically it should break it up for you on YouTube so that you can select the information that you actually want to see. So without further ado, I'm going to go over the questions. The first question says, identify the subatomic particle with the smallest mass. So this is going to come up in lots of different questions, so I do want to go over this quickly. So we have 3 subatomic particles. We have the proton, which has a mass of 1 AMU, a charge of plus or plus 1, and a location of the nucleus. We have the neutron, which is N or N0, which has a mass of 1 AMU. Okay, I'm going to use N0 because the exam uses N0. Has a charge of neutral. Neutrons are neutral, and it's also found in the nucleus. Then finally we have the electron, which has a mass of approximately 0 AMU, has a negative charge, or -1, and is found outside of the nucleus. So it's surrounding the nucleus such that an atom is mostly empty space. It has a dense nucleus which contains the protons and the neutrons and all of the mass, and then it has a bunch of empty space, and then the electrons are on the outside. Note that if a proton was blown up to the size of a blueberry, the electron cloud would be about the size of a football stadium. So again, an atom is mostly empty space. So with this information, we can answer several of these different questions. Okay, so it says identify the particle with the smallest mass. Well, the electron has a mass of about 0 AMU, so it is the subatomic particle with the smallest mass. Question 2 says, the atomic number is equal to. Well, the atomic number is the number of protons, and above each atom on the periodic table, so for example hydrogen has 1 proton, helium has 2, lithium has 3, beryllium has 4, boron has 5, so on and so forth. Said another way, something with its 2 protons in its nucleus behaves like helium, and helium is known for being an inert, unreactive gas, and it's lighter than air. So if you put it in a balloon, the balloon will float. So that's basically how the periodic table works. Again, please watch the video lecture if you missed that. So the atomic number is equal to the number of protons. Q3 says, what does X represent in the following symbol? So this is the atomic number, which as we just discussed is the number of protons in the nucleus. This is the mass number, which is equal to the number of neutrons and the number of protons because they both have mass. And over here is the charge. So the number of protons is fixed by the atomic number. Once an atom is an atom, it will never change in a chemistry class. The charge is based on the relative number of protons and electrons. So this has 35 protons, so if its charge is neutral, nothing is written here, then it also has 35 electrons. If it were negatively charged, it would have 36 electrons. If it were positively charged, it would have 34 electrons. Note that if it were -2, it would actually have 37 electrons, 2 extra electrons. So this is basically how it works. So what you want to do is get your periodic table, find atomic number 35, because this is the atomic number, and atomic number 35, or something with 35 protons in its nucleus, is called bromine. Number 4 says, determine the number of protons, neutrons, and electrons in the following. And if you haven't watched the first 3 questions, it's probably a good idea to watch those before doing this one. So the atomic number, this is the atomic number, but it's also the number of protons. Okay, so this has 18 protons. And the mass number is telling us the number of protons and neutrons. Said another way, the number of neutrons equals the mass number minus the atomic number, and the atomic number is the number of protons. So in this case, the mass number is 40. The mass number is written up here, as you can see here, where I explain the nomenclature, minus the atomic number, 18, which is equal to 22. Since this thing is neutral, it has no charge, the charge would be written here, the number of protons and the number of electrons are equal. So it's got 18 protons, 22 neutrons, and 18 electrons, and this is the correct answer. It says, what element is defined by the following information? The piece of information that defines the element is the number of protons, which is also equal to the atomic number. So we find atomic number 11, which is 11 protons, and we find that this is called sodium. Note that the periodic table that I give you gives you both the names and the symbol. So number 11 is Na, called sodium. So if you get words, you get it, and if you have symbols, you can also get it. This question says, how many electrons are in a neutral atom of magnesium? So we have to find magnesium on our periodic table. Magnesium is atomic number of 12, which means it has 12 protons in the nucleus. Because it's a neutral atom, that means the number of protons and the number of electrons are equal, so it also has 12 electrons in the electron cloud. It says, an atom of carbon-13 contains blank protons. So the mass number is 13 for carbon-13, however that doesn't matter. For the number of protons, the protons is equal to the atomic number. So we're just finding carbon on the periodic table, which is right here, which has 6 protons, which is answer choice letter A. Question 8 says, which of the following elements is not a metal? So when we look at the periodic table, the metals are everything to the left of this staircased line. So we have this bolded staircase line here. Anything touching on two sides is a metalloid, with the exception of aluminum, which we consider a metal. Anything to the left of this line, which does include the lanthanides and the actinides down here, but I wouldn't ask about those. Anything on the left of this line is a metal, with the exception of hydrogen, which is not a metal. So these are all metals. So what's the first choice? The first choice is barium. Barium is right here, which is a metal. Again, the staircase line, touching it on two sides, is going to be your metalloids, where aluminum is actually a metal, and then over here is your non-metals. All right, so gallium is right here, it's a metal. Xenon is the answer, because xenon is right here, it is a non-metal. All right, lead is right here, which is a metal. I understand it when you're first doing this, you got to hunt around for them a little bit. And then finally magnesium is over here, which is also a metal. So the only one that's not a metal is xenon right here, which is a non-metal. Number 9 says, an ion is an element that has a different number of blank. An ion is an atom with a charge. It could be a positive charge if that's a cation, or a negative charge, that's an anion, but an ion is an element with a charge. The way you get a charge is have a different number of electrons. If something loses electrons, it will have more protons than electrons, and it will be positively charged. If something gains electrons, it will have more electrons than protons, and it will become negatively charged, but either of these atoms with charges are ions. Right, so question 10 asks us about isotopes. It says an isotope is an element with a different number of whatever. So ion and isotope sound kind of similar, but they're different. Isotopes have different mass numbers. The way they have different mass numbers, but they're the same element, is having a different number of neutrons. Remember, the neutrons and the protons have mass. So having a different mass number means a different number of neutrons. If you have a different number of protons, it's a totally different element. So this is how we have isotopes. Again, this is a very brief description, and if you didn't come to class that day because you missed class, please make sure you do watch the lecture video that goes over this information. Question 11 says, semiconductors are, well, semiconductors are your metalloids. Remember, your metalloids are things touching the staircase line on two sides. The most famous one is silicon. Note that aluminum is a metal, so it is not a metalloid, but your metalloids are your semiconductors. So if you saw the previous question, this one is straightforward. It says, which of the following elements is a metalloid? So again, a metalloid is touching the staircase line on two sides. If we look at the possible choices, the example of the metalloid is arsenic, because arsenic is touching the bolded line on two sides. So arsenic is our metalloid. Question says, how many electrons does Se2 minus possess? So we have an ion, an anion, because it's negatively charged. So if we find selenium on our periodic table, we find that it has 34 protons. That means it has 34 positive charges. But this one is 2 minus, which means that it has 2 extra electrons. In order for this to have 2 extra electrons, it must have 36 electrons. So if it has 36 electrons and 34 protons, its overall charge will be 2 minus. Number 15 says, give the number of electrons in K+. It's very similar to question 13. So K+ is going to have 19 protons. In order to have a positive charge, it must be missing an electron. So when it's missing one electron, it only has 18 electrons. So again, ions form by gaining and losing electrons. Positive ions have less electrons than they do protons, and negative ions have more electrons than they do protons. It says, as we switch into organic chemistry, compounds that have the same molecular formula but a different arrangement of atoms are called isomers. So this would be an example of, for example, pentane, a 5-carbon chain, versus a 2-methylbutane, which is a 4-carbon chain with a methyl group sticking off. And we'll get into some isomers down here, so I'm not going to go into more detail in this question. I will, however, note this is our third I word. We have ions, which differ in the number of electrons that they have. We have isotopes, which differ in the number of neutrons in the nucleus, or a difference in the mass number. And we have isomers, which differ in the arrangement of atoms in a carbon chain. So 3 I words, and you need to know the difference between each of them. It says, the special feature that determines the family name and chemical reactivity of an organic compound it is found in is called a functional group. All right, and on your reference table for organic compounds, you have an entire list of functional groups that are possible. Okay, so these are the different functional groups that you have right here. So those arrangement of atoms are called functional groups, and you just have to kind of remember that. All right, this one says the functional group contained in the following compound is, so if we look here, we have this C double bond O, which is called a carbonyl. And if we look down at our list here of functional groups, which again is provided on the exam, you're going to have 4 functional groups that have a carbonyl. This carbonyl is attached to an H or some carbon containing group. Okay. This carbonyl is attached to 2 carbon containing groups. This carbonyl is attached to an OH, and this carbonyl is attached to an O and then an organic group. So if we look here, in this case, this carbon is only attached to one O, the carbonyl carbon. So it can't be a carboxylic acid, and it can't be an ester, because this carbonyl carbon is attached to an O other than the double bond O. This one is not. Now let's look at the ketone or the aldehyde. What this line means is some other carbon containing group. So if we look at this example, it's attached to 1 carbon containing group and an H. In a ketone, you have 2 carbon containing groups. In an aldehyde, you have 1 carbon containing group and an H. So this one is an aldehyde and not a ketone. So it is choice letter E. If you haven't watched the organic lecture, it's a very good idea to do that, because it'll make these questions easier once you have a broader idea of how to approach these problems. Number 18 says, the functional group contained in the compound CH3, CH2, NH2. So if we look at our list of functional groups, okay, what we find is there's only 2 that have N's in them. All right, and this N is bonded to 3 other things. If you look at this N, it's bonded to 2 H's and this. This N is bonded to a C double bond O. This molecule does not have a C double bond O. So, by finding the N, we know it's either this functional group or this functional group. And what we're looking for is the C double bond O. If it has a C double bond O, it's an amide. If it doesn't, it's an amine. This one does not have a C double bond O, so this one is an amine, choice letter C. Number 19 says, carbon atoms always have how many bonds, okay? And this is going to come up again in the next question and the question after that. So when it has how many bonds, carbon atoms always have 4 bonds, and that allows us to determine how many hydrogens are not shown in the formula, like in the next question. The next question says, the molecule below contains only C and H. Hydrogens are not shown. How many hydrogens are attached to the circled carbon? There's a typo there. All right, when we look at this, what we notice is this carbon has 1 bond to carbon. Therefore, it must have a total of 4 bonds, or 3 bonds to H. So the answer to this question is 3. How about this carbon? It's bonded to 2 other carbons, so it must have 2 bonds to H. And how about this carbon? This carbon is bonded to 1 other carbon, so it must have 3 bonds to H. And that's basically how it works. Question 21 says, the molecule below contains only carbon and hydrogen. What is the total number of hydrogens on this molecule? So there's 2 ways to do this. The first way is you have 1, 2, 3, 4, 5. Alkanes, this is an alkane, have the formula CnH2n plus 2, where N is simply the number of carbons. So in this case, we have C5, which means we have H, 2n plus 2. 2 times 5, which is 10, plus 2, which is 12. So this N is just the number of carbons. So once you count 1, 2, 3, 4, 5, you plug that in, and then it's 2n plus 2, which is 2 times 5 plus 2, which is 12. There's another way to do this, of course. Remembering from the previous question that hydrogen has 4 bonds, we have 1, 2, 3 hydrogens on this, and then the 4th bond is to carbon. This carbon is attached to 2 carbons, so it must have 2 hydrogens. This carbon is attached to 2 carbons, so it must have 2 hydrogens. This carbon is attached to 2 carbons, so it must have 2 hydrogens to have 4 bonds. And this carbon is only attached to 1 carbon, so it must have 3 hydrogens to have 4 bonds. Now if we count, we have 3 plus 2, which is 5, plus 2 more is 7, plus 2 more is 9, plus 3 more is 12. So either way you do it, you find that this has 12 hydrogens. Alright, for number 22, it's really important with the naming stuff that you take a look at the video if you haven't already, because I'm going to go through this very quickly. It says, what is the name of this compound? So you want to find the longest chain and circle. So this is the longest continuous carbon chain. In this case, it's just straight across. So we have 1, 2, 3, 4, 5 carbons. So we go to our sheet here, and we find 5 carbons in a chain. This is called pentane. So a 5 carbon chain is called pentane, choice letter A. Alright, number 23 says name the following compound. So we circle the longest continuous carbon chain, which in this course I'm always going to write in the obvious direction, if you will. Okay, so this is our longest continuous carbon chain. So we have 1, 2, 3, 4, 5, 6 carbons. We go to our sheet, we find C6. This is called hexane. So the base name of this molecule is called hexane. There's something sticking off of this hexane, a 1 carbon group. A 1 carbon group is called methane. However, when it's sticking off, we don't call it methane, we change the suffix to methyl, YL. We now need to give it a number. Our choices are 1, 2, 3, 4, 5 methyl, or 1, 2. So we simply count from either end of the chain, and we go to the methyl group. We pick the lower number. So a 2 methyl is better than a 5 methyl, so we call this a 2 methyl hexane, which is choice letter A. Alright, if you haven't watched the previous 2 questions, please start with those. It says, what is the name of this molecule? So again, circle the longest carbon chain. 1, 2, 3, 4. So this has 4 carbons. We go to C4, and we find that the base name is butane. what's sticking off of this? Well, now we have two 1 carbons. So a 1 carbon is called a methane, but if it's sticking off, it's called a methyl, but there's 2 of them. So we call it dimethyl. So this is a dimethyl butane. We now need to give a number. Our choices are 1, 2, or 1, 2, 3. We pick the lower number, 1, 2 in this direction, so we start from both ends and number and find which one is lower. So this is called a 2, 2 dimethyl butane. Again, I'm going over this in 30 seconds. It's really important to watch the video that goes over the lecture if you missed that lecture. Alright, so if you haven't watched the previous questions, please start with those. And there isn't one exactly like this on the test, but I do want to point out what isomers are. It says, which of the following pairs of formulas represent isomers? So the first thing you want to do is circle the longest chain. Alright, isomers are the same formula, but a different number or arrangement of atoms. So if we look here, in both cases, the longest chain is 1, 2, 3, 4. 1, 2, 3, 4. And both of them have a methyl group sticking off. So these both have the base name butane for 4 carbons, and a methyl group sticking off of carbon 1, 2, because this is a shorter direction, 1, 2. These are the same molecule. These are both 2-methyl butane. And the 2, whether you need it or not, is arguable, but for this course, 2-methyl butane is good. Let's take a look at this question. In this question, we have the longest carbon chain, which we want to go ahead and circle. So we have this right here and this right here. These are both a 4-carbon butane chain. They both also have 2 methyl groups sticking off. So this is a 2,3 dimethyl butane, and this is a 2,2 dimethyl butane. Those two are isomers. Let's look here. In this case, we have a 4-carbon chain, and in this case, we have a 4-carbon chain. These are both butane, so they're the same molecule. Let's look here. In this case, we have a 4-carbon chain, and in this case, we have a 3-carbon chain. So this one's butane, and this one's pentane, or propane, excuse me. These two aren't even the same, all right? They're just a different number of carbons. And the same thing here. Here we have 5 carbons, or we have a dimethyl propane, and in this case we just have propane. It's only got 3 carbons. These are not even the same molecule, okay? So if they don't have the same number of carbons, they can't be isomers. But in this case, we have the same number of carbons. Both of these have 6 carbons, or said another way, both of them are dimethyl butanes. But in this case, the methyl groups are on 2 and 3, and in this case, they're both on carbon 2. So this is 2,2-dimethylbutane, this is 2,3-dimethylbutane. Those are isomers. Same formula, same number of carbons, in this case 6, however, a different arrangement of atoms. That is isomers. I'd like to take this opportunity to thank you for watching some of this video, and I really appreciate it. All right, so good luck on the exam.